Alright, here we go with the chapter review. So it says 2 1/2 multiplied by 3 1/3. So what I'm going to start off by doing is creating a rectangle to multiply. And I'm going to divide it into fourths. And then I'm going to put on top my 2 1/2. And I'm going to put my 3 1/3 on the side. And so now I'm going to multiply where the numbers meet. So 2 times 3 would meet in this box here. And so I'm going to do 2 times 3 gives me 6. And now I'm going to do 2 times 1/3. And I can think about this as 2 over 1 times 1 over 3, which would give me 2 on top and give me 3 on the bottom. And then I'm going to do 1/2 times 3 over here. And I can think about that as 1/2 times 3 over 1. And that would give me 3 over 2. And then finally I'm going to finish with 1/2 multiplied by 1/3. 1 on top, and when I multiply across the bottom I get 6. So I have 1/6 in my final box. But I'm not done yet. I have to take all of these fractions and whole numbers and add them together. And so I'm going to start off by writing my whole number here, 6. And now what I'm going to do is I'm going to take the rest of the fractions and I'm going to add them with each other. Alright, so here I have 3 over 2, which I want to make a common denominator for all these fractions. And I notice that 2, 3, and 6 all go into 6. And so my 3 over 2 is going to change to 9 over 6, right? Because you have to multiply 2 to get to 6. You have to multiply 3 by 3 to get to 9. And then I'm going to do 2/3 would change into 3 over 6. And then 1/6 would just stay at 1/6. Alright? So now let's go ahead and add these fractions together. So I'm just going to add these right here. So obviously across the bottom that's going to stay the same. So it's going to be 6 on the bottom. And then on the top, if I do 9 plus 3 plus 1, that's going to give me 13. So I have 13 over 6. Now I want to write this as a mixed fraction. And so I'm going to say, how many times does 6 go into 13? How many times? Well, 6 times 2 is 12, so it goes in there twice, and then there's 1 left over. So I can write 13 over 6 as 2 and not 1/3, 1/6. And then I'm going to add it to my big 6 that I had. So 2 1/6 plus 6 is going to give me 8 1/6. And that would be my final answer here. Alright, so again we use this little Punnett square or rectangular multiplication. We got 2 1/6 from the fractions, and then we had 6 as the whole number. So we added them together and we got 8 1/6. So now we're looking at the next problem here, and it says 3 5/6 minus 2 3/4. And so what I'm going to start off by doing is subtracting those big numbers out in front, those whole numbers. And so 3 minus 2 equals 1. And now I don't have to worry about them. I can pretend that they're like not even here. And now I can do 5/6 minus 3/4. Okay? 5/6 minus 3/4. Now you're probably thinking, okay, first thing I got to do is change that denominator to a common denominator. And so I'm thinking, what is a number that both 6 and 4 go into that's a small number? Well, 6 goes into 12 and so does 4. So I'm going to put them both over 12. And then we multiplied 6 times 2 to get to 12. So now we're going to multiply 5 times 2 to get to 10. And now what I'm going to do is look at how many times do I have to multiply 4 to get to 12. I'd multiply it by 3 to get to 12. So now I'm going to do the same thing for my 3. I'm going to multiply it by 3 as well. 3 times 3 will give me 9. And so now I have 10 minus 9. That's going to give me 1. And then my denominator of 12 would stay the same. So my final answer here would be 1 over 12. All right, looking at 3, it says turn 2 over 9 into a decimal using long division. Does it terminate or repeat? So here I have my little divider sign, and I'm starting with 2, right? And I'm dividing it by 9 people. So 2 would be my dividend, 9 would be my divisor. And now I'm saying, okay, how many times does 9 go into 2? Well, it does not go into 2. So I'd put a 0 up here. And then I would do 0 times 9, which would give me 0, right? And then if I subtract 2 from 0, I'm going to keep my 2. And then what I can do from this point is turn this 2 into 2.000, right? 2.000 is the same thing as just 2, but it's going to help me here with my dividing. And so I'm going to take this 0 and bring it down, and now I have 20. And now I can say, how many times does 9 go into 20? Well, 9 goes into 20 2 times. So then I multiply 2 times 9, and it gives me 18. And then 20 minus 18 is 2. So I need to bring down another 0 and say, how many times does 9 go into 20? Well, 9 goes into 20 2 times again. And so I do 2 times 9, and I get 18. And I subtract once more, and I get a 2 here. Looks like we have a little theme going where I always get 2 left over. And so I bring down my 0. How many times does 9 go into 20? Well, it goes in there twice. And here we see 3 2s in a row, so it tells us that it's repeating. All right, so my answer would be 0.2, the line over the top, because that shows that it's repeating. And then I would write repeating. Now, if it did end, right, if it didn't go on forever, and we didn't have a remainder of 2 each time we subtracted 18 from 20, then it would be a terminating decimal, okay? So now we're looking at 4. Write an addition expression and a multiplication expression to represent this diagram. Then find the total distance. So I'm going to go ahead and get rid of what we have here. And when I'm writing my addition expression, I'm literally just going to put a plus sign, adding each of those pieces. That's all you need to do for adding. And now when we look at multiplication, I'm going to take a look at, first off, how many numbers do I have? Well, I have 3 numbers. What are those 3 numbers? Those 3 numbers are all 8s. So you'll see here my multiplication expression was 3 times 8. Now if you notice, each give me 24, which makes sense, right? This here, if I go forward 8 times, or I go forward 8 3 times, it's going to give me 24 feet in total, no matter whether we write as multiplication or addition. All right, now we're looking at problem 4 here. It says 4 plus negative 2 plus negative 6. So what I like to do is for these positive numbers, write these little plus signs or plus chips, they call them in your book. and then you're going to add these negative signs. So here's my -2, and then I still have -6, so I need to add 6 more here. All right, so now let's look at what cancels out. Well, these 4 positive and negative chips would cancel out, but then I still have 4 negative chips left over, and so my final answer would be -4. And then we see part B here. It says 4 times -3. So I can think about this in terms of, okay, let's say I'm at a number line. Let's say I'm at 0 on my number line, and I'm heading in the negative direction. So I can begin by saying, okay, here I'm at 0. I'm going to move 1, 2, 3, 4 places in the negative direction. Actually, I can do 3 here because it's 4 times 3, so I'll do it by moving -3 4 times. 1, 2, 3. Okay, there's my first move, and here I'm at -3. And then I'm going to move 1, 2, 3 again, and now I'm at -6. Now I'm going to move 1, 2, 3 again, and now I'm at -9. I'm going to move 1, 2, 3, my fourth and final time, and now here I am at -12. Does that make sense? So we're moving -3 each time, and then we're moving -3 a total of 4 times. So here I have 4 numbers representing my jumps. And remember, we always start at 0. Okay? So my final answer would be -12. So that's using the number line, and then up above is using those chips, positive and negative ones. So here, number 5 says, write an addition expression and a multiplication expression to represent this diagram. Then find the total distance. So again, for multiplication, I'm going to take a look at, okay, how many numbers do I have here? Well, I have 2 2's. Okay? I have 1, 2, number 2's. And then I'm going to say, how many times do I see 7? I see 1, 2 7's. So I'm going to do 2 2's multiplied by 2 7's. And this would be 4 plus 14. And that would give me 18. Okay, so this would be multiplication right here. 2 2's plus 2 7's equals 18. And then if I wanted to write it as addition, I would say 2 plus 7 plus 2 plus 7. It's just like I'm writing a plus sign in between each of these pieces because I'm adding them together. And again, I'm still going to get 18 here. So the total distance would be 18. Then we see problem 6. It says use a rectangle diagram to represent this multiplication problem. Now when it says rectangle diagram, it's not asking about drawing it into fourths and doing this whole thing, okay? It's talking about dividing this into the fractions that it has shown. And so when you see this multiplication sign, this means of. So you can think about this as 5 sevenths of 3 fifths. Okay, and since it's of 3 fifths, we're going to start with 3 fifths. So I'm going to divide this into fifths by drawing 4 lines. Okay, and now I'm going to divide my fifths into sevenths by drawing 6 lines. And now I need to take a look at what I'm shading here. So of those sevenths, I'm going to be shading 5 of them, okay? So here are my sevenths going down. There's 1, 2, 3, 4, 5. And then how many of my fifths am I going to shade? Well, I'm going to be shading 3 of them. So now I'm looking horizontally. I'm going to shade 1, 2, 3 of my fifths. And so now I need to look at where are my shadings overlapping. And so you'll see my purple and blue overlap here. So how many total squares do I have? That's going to be the bottom of my fraction. And if I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keep going, I'm going to get to 35. And then if I count what's shaded in yellow, what's overlapping, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of those tiny boxes that are overlapped in shading. So my final answer would be 15 over 35, and this drawing right here of the diagram represents this multiplication problem. Now you can check your answer by simply multiplying across the top, and you would get 5 times 3 equals 15, and 7 times 5 gets 35. But the reason that we have you show it in this diagram is because then you understand why it equals 15 over 35. You can visually show it rather than just saying, oh, well, I multiply them 2 numbers. All right, so then 7 says the opposite of negative 10 is, well, this one's pretty easy, right? Opposite of negative 10 is 10. The opposite of negative 5 is 5. Opposites always add together to equal 0. Negative 10 plus 10 will give you 0, okay? So if it gives you a number, it just wants the negative or positive version of that number. That would be the opposite. And here we see 2/3 multiplied by 3 over 10. Here we don't need to draw a diagram, so I can just multiply across the top. So I'm going to do 2 times 3 equals 6, and 3 times 10 equals 30. But I'm not finished yet. I need to look at what both of these numbers can be divided by. And here 6 can be divided by 6. 30 can be divided by 6. So now we're going to have 1 over 5. Final answer. And then we have 2 1/2 multiplied by 3 3/4. So you're probably thinking, okay, we could probably just do 2 times 3, and then we could do 1/2 times 3/4. But that's not exactly how we can do this. And so what I'm going to do is turn these into improper fractions. You could also draw your rectangle, and you could do 2 1/2, 3 3/4, and then you could multiply and then add all of the sums together. And then what we're going to do instead is change these into improper fractions, so that way you can see both ways. And I'm going to say, okay, 2 1/2 is going to turn into 5 over 2, and then my 3 3/4 is going to change to 15 over 4. And if you're wondering how we got that, well, I just do 4 times 3, and then I do 3 plus 3 on the top. And so we get 15. So now I'm going to multiply these together. So if I multiply across the top, 5 times 15 is going to give me 75. And then across the bottom, and we're going to do 2 times 4 is going to give me 8. So I have 75 over 8. So I got to look at how many times does 8 go into 75, because this is the same thing as 75 divided by 8. Well, I know that 8 times 9 gives me 72. So I know I'm going to have a big old 9 in front, but 72 is 3 less than 75, and so I'm going to have 3 left over. So it'll be 9 3/8. Can I reduce this? No, I cannot. So that'll be my final answer. Next, I'm looking at problem 10, and that is negative 42 plus 22. plus -4 plus 5. Now, the chips would take too long, and the number line would also be kind of messy. So I'm just going to do -42 plus 22, and that would give me -20. And now I'm going to do -4 plus 5, and that's going to give me a +1. So now if I add together -20 plus my +1, that's going to give me -19. All right, and here we got a final answer. We showed our work, so we'd be all good. Next problem, I'm going to do the same thing. I'm going to start with 52, and since they're both negative, meaning we're going in the negative direction the first time around, and then we're going negative again, I can just add these two values, 52 and 12, and that would give me 64. And then since they're both negative, my answer would be negative. All right, looking at this last problem here. It says 80 plus -35 plus -5. So first I'm going to do 80 plus -35. So I'm at 80 on my number line, and then I'm going to add -35. So let's see what happens if I jump -5, 10, 15, 20, 30, or 25, 30, 35. If I go 5 less each time, I'm going to end at 45. All right, so that is, if I subtract 35 from 80, I'm going to be at 45. But now I need to add -5, which means I'm going to go 5 back again. So now I'm going to end at 40. -40. Or excuse me, +40, right? We're not in the negatives. So my answer here would be 40. All right, now this question here is about scaling and graphing. And so first things first, I'm going to try to figure out what my x and y axis are. So I have my quarters, and then I have my number of flakes thrown. So I'm thinking about my independent variable, which can stand alone. It's like something that progresses over time. And then my dependent variable is going to be what depends on the independent variable. It depends on the other thing. So what I'm asking myself now is, does my quarter depend on the number of flakes thrown, or does my number of flakes thrown depend on my quarter? What am I trying to test? Well, I'm trying to see if the number of flakes thrown is depending on the quarter. And so since it's depending on something else, number of flakes thrown is going to be my dependent variable. And that here would be my y. So number of flakes thrown is my y. And that is on the vertical axis. And then I'm looking at what my independent variable is, or my x. That's going to be my quarter. That's typically going to be like your time. So you're going to see like how time would affect temperature, how time would affect the number of flakes thrown, or how time would affect the number of points you score. So a lot of times time will be down here. So here I have the quarter, And this is going to be easy to space out because I have 1, 2, 3, 4. And then I'm going to look at how many spaces I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 spaces here, and I have 4 quarters to place on those 18 spaces. I need to have these spaces evenly apart, and so since we start at 0, I'm going to count 1, 2, 3, 4, and that's where I'm going to put my first quarter, because if I have 18 spaces and I need to divide it by 4, that's going to give me 4 with 2 left over. Alright, so I'm going every 4 because I know that's a safe bet. 1, 2, 3, 4. I'm going to put another 2. 1, 2, 3, 4. I'm going to put my 3. 1, 2, 3, 4. I'm going to put my 4. And there's only 4 quarters in a game, so I'm all good there. One more time. This is my 1. This is my 2. This is my 3. This is my 4. Alright? And now I need to do my dependent variable. So I'm going to get rid of that here. Get rid of this too. And I'm assuming that this is about 18 markers as well, or 18 squares going up. So now I'm going to do 18 divided by my highest number of flags thrown, which is 7. And that's going to give me 2 and 4 sevenths, right? 7 goes into 18 twice with 4 left over. And so now what I'm going to do is space these out every 2. So here we go. I'm going to start at 0. Which is right here. And I'm going to go 1, 2, put a 1, 3, 4, put a 2, 5, 6, put a 3, 7, 8, put a 4, 9, 10, put a 5, 11, 12, put a 6, 13, 14, put a 7. And I'll make this extra clear for you. We go 2 spaces up. We're right there. 2 spaces up, 2 spaces up, 2 spaces up. Alright, notice these are all 2 apart. And then these down here are all 4 apart. Okay? So 4 apart, and then here up here, 2 apart. So that would be my scaling. Alright? Making sure that they are an even distance apart from each other. And now what we're going to do is plot these points. So remember, these points are written as x, y when we graph them. Okay, so like if we put a point here, we would write it as our x first and then our y. So in this example, we take a look at where it is on our x. Well, it's between 1 and 2, so that would be 1.5. And it's up here at 4. So it would be 1.54. Alright, that was just an example. If we put a random point there. So here, if we look at what our x is, I'll do this in yellow. Our x is 1. And then we take a look at what our y is. I'll do this in red. Our y is 2. So my first point that I'm going to be plotting is 1 here on my x. And then I'm going to go up 2. Alright? So this black dot right here would be my first point. Then I look at the next one. I'm going across 2. Whoops. If you guys notice my mistake here, I was supposed to start here at quarter 1 and then go up 2. Got to pay attention to our numbers on the side. So here I'm at 1, 2. And then this next one is 2, 4. So here I am at 2. And I need to go up to 4. So I'd be meeting right there. Then I'm taking a look at 3, 4. So I'm at 3, and again I'm going up to 4. And then I'm at 4, going up to 7. So 4 going up to 7. Alright, so those would be my points. And you would typically not have these lines here. I just drew them because they help me stay with my X on the graph down here. So these are my points. Have I answered everything I needed to? I'm missing one thing, and that would be my labels. So here I have my quarter label at the bottom, but I haven't labeled what these things are on the side. It needs to be my flags thrown. Alright, so my Y is the flags thrown, and then my X is the quarter number. And then I could label even with a title, I could say like quarter and flags. Alright, it all looks good. Hopefully this makes sense to you, but really you just want to focus on keeping your scale the same distance apart. Okay, and then you also want to make sure you label. And then you want to make sure that your points are in XY form. Alright, let me know if you have any questions. One neat trick that I'll leave you with is that I remember X comes before Y because X comes before Y in the alphabet. So thank you very much.